This is chapter 10, and we need to talk about hypothesis testing. This is the basic idea, all right? It is actually quite straightforward. There is a population, and somebody's making a claim about the population. For example, let's say that somebody's claiming that the population percentage is 70%, right? So the population percentage is 70%. But this is just a claim, it's a hypothesis, right? It is not totally certain that it's true or untrue. So let's mark this with a question mark. And what we are going to do is going to test this hypothesis based on a sample. Notice this is the hypothesis about the population. We're not going to measure the whole population. We are going to take a sample out of the population. All right, so we assume that this is a random sample, and the claim is about the population percentage, right? So we need to go and find a random sample and find the sample percentage. Now, the sample percentage, for right now, let's call it P with a hat. All right, so P with a hat. This is the population, this is the population percentage with a P, and the sample percentage with a P with a hat. And we are testing this number with this other number, right? For the sake of illustration, for the sake of an explanation right now, let's say that this is 30% or 0.30, right? Now the question is this claim correct? And the way we are going to test this claim is basically compare this, which is the population percentage, with the sample percentage. And if the sample percentage is too different from the population percentage, we are going to reject this claim. The next step will be, all right, is this number compatible with this number? Or is this number close to this number? And remember, this is just a claim, right? This is a hypothesis. This is actual data. And because, like in this case, this number is too different from this one, we are going to reject the claim, right? So we reject the claim because this number is not close to this number. And we are going to do this process basically the same. Let me give you another example, right? So let's say this is a population, and somebody makes a claim about this population, right? So let's say that the claim is that the mean of the population is 30,000. Oops, 30,000. Now this is just a claim, right? Let me emphasize, this is just a claim, or this is just a hypothesis. The problem is, how do you test the hypothesis? Well, we are going to test the hypothesis not by measuring the whole population, because it will take too long. We are measuring, or we are testing this claim based on a random sample, right? So we take a random sample out of this large population, and it is always assumed that this is a random sample, right? So you take a sample, and notice this is a claim about the population mean. So we take a random sample and we find the sample mean. All right, so the sample mean in this case, well, we are going to label that with an X bar. And for the sake of this illustration, let's say that X bar is equals to well, let's say it is equals to 70,000, right? Again, we are going to compare this number with this number. And remember, this is just a claim, right? We are going to test this claim with actual data. So we take a random sample, we find the corresponding parameter or corresponding statistic, and we are going to compare this with the claim, and this is the actual data. So if this number is too different from that one, we are going to say this claim is rejected, right? So you reject the claim And the hypothesis testing process is basically this, right? We have a claim or we have a hypothesis about the population. And then to test that, we are going to take a random sample. And if this claim is related to the percentage of the population, we take the percentage of the sample. And then we are going to compare the sample percentage with the population percentage. If they're too different, we are going to reject this claim. Because remember, this is just a claim, right? Just a hypothesis. And then if the claim is about the population mean, this will be just a claim. We need to take real data taken out of the population in form of a sample, and this is the population mean, so this will have to be the sample mean. We always take the corresponding statistic, right? And then we compare this claim with the actual data, and if they're too different, we reject the claim. All right, so that's the basis. Now the next context, the next subject in this process is this. We need to talk about hypotheses. More formally, we are going to do two hypotheses. We have the null hypothesis. Hopefully this is big enough and you can see it. And the alternative hypothesis. We will always have two hypotheses. First one, you have the null hypothesis. I'll tell you more about this one. And then the alternative hypothesis. There are only two options, right? You either accept this one or accept this one. Sometimes you say, well, I reject this one, which means you accept this one. And there's no other option, right? There's no third alternative. This will be it, the null and the alternative. This one is typically written like H sub 0 colon. And this one is typically written as H1 colon. And one example will be, for example, the null hypothesis is that the mean is equals to 30. And as a matter of fact, the null hypothesis is always about equality, right? It is always an equation. So you will always have maybe the mean is equals to 30 or the percentage is equals to 45%, something like that, right? So this null hypothesis will always be equal. And then the alternative will be, well, it could be maybe greater, or sometimes it could be less than. But for right now, let's leave it as a greater than 30. And it will always be the same number here and here. And as a matter of fact, for example, in the first case we talked about earlier, so we have that the percentage was 45%. I forgot. Well, let's say that the claim was that the percentage was 45%, right? So you have the null being that the percentage is 0.45, and the alternative will be that the percentage was, let's say, less than 0.45. This is the equal sign, and this is always either the net less than or maybe the greater than. Now in this case, the percentage equals to 0.45 will be in the center. I'll talk about this more in a minute. And then this one being less than 0.45 will be represented by the left side. We'll talk about this more in a minute. But the null hypothesis is always in the center. This is the center hypothesis. And this one, you call it the extreme hypothesis, because it will either be on the left side, but not only on the left side, but on the far left, or maybe on the far right, but the center hypothesis will be the null hypothesis, which is always equal. And then the alternative will be on one side, maybe on the other side, but it will be on the far left, on the far right. Another example, and example of hypotheses will be this one. Example of hypothesis. Now, the null hypothesis will always be, well, it could be about the percentage like this one, it could be about the mean of the population. And remember, the null hypothesis is always an equal statement. So it could be that the mean is equals to 30, which is the center hypothesis. And then graphically, this will apply in like a normal distribution. This will be the null hypothesis in the center. And all this area will be the null hypothesis. Now the alternative, well, it depends on the context, but the alternative could be, for example, that the mean is greater than 30. This would be the alternative, and this would be the center hypothesis, this would be the extreme hypothesis, just like in this case. But notice this is greater than, so the greater than implies that we are on the far right. So this will be represented by this graph, right? The null hypothesis is in the center. The alternative hypothesis will be in the far right. This will be the alternative area, and this is the null area. And the highest possibility will be the null hypothesis, and this one is actually quite small. The probability of us accepting the alternative is typically very small. The probability of us accepting the null hypothesis is typically much, much larger, like maybe 95% versus 5% or something like that. Now, this will be the case in all kinds of problems. The null hypothesis will be equal, and that means that you are in the center of the distribution. The alternative will be either on the far right, like this one, or on the far left, like this one right here. And notice this one, which is the alternative area, is determined by this area. In this case, the alternative area is implied by this area, or determined by this area. This typically is called the significance value, or alpha, like the fish, right? And this will be the easiest number to find because it will always be there. You will always be given this number. It's called the alpha, or the significance value, alpha. Alpha, like this. Now, let's be more specific, okay? We are going to do one specific problem in a minute, but before we get to that point, I need this number in a minute. Let's do this. All right, so let's say that the claim is, somebody's making a claim that the percentage of the population is 70%, right? And then we are going to use an alpha of 5%. Now this one is very easy to find. You don't really have to worry about this one because this will always be given, right? You will be told in the context of the problem, use an alpha of 0.05 or an alpha of 0.01 or something like that, right? So in this case, this will be, well, this is the significance level. And then we are going to test this claim, but before we actually do it, The first thing we need to do is write the hypothesis. All right, the null hypothesis is that the percentage is equals to 70%. Notice that the null hypothesis is always about equal sign, right? So this is an equation, that's why this is the null hypothesis. Now the alternative, all right, it is not very clear which one we are going to use, but for the sake of this illustration, let's use p greater than 0.70. It will always be clear from the problem which one we need to use, and I'll tell you about this in a minute. But if this is the problem, the graph is going to look like this. It will be a normal distribution, more or less. It will be a bell shape, at least, and the center is the null hypothesis. Now this one says greater than. Now why is this greater than? Well, it will be clear from the problem. For right now it is not very clear, but let's use the greater than for the sake of this problem. Because this is greater, it will be on the right hand side. Now this area right here is 0.05. Now you have a cutoff right here. This point right here is called the critical value. And we are going to find it later, not right now. But there will always be two areas, the null hypothesis area, which is in this area, and the alternative hypothesis area, which will be either on the right-hand side like this one, or on the left side. And this 0.05 determines the alternative area, and we need to find this point. And we are going to find this in a minute. Now, in this case, and we'll talk about this more in a minute, this is about percentages, right? So this is a normal distribution. Now, whenever we're talking about percentage, we always deal with normal distribution, right? So this is basically the problem. For right now, we are going to do this. We are going to find this critical value, right? And we are going to find it in the context of this being a normal distribution, right? Notice that this is 0.05. This right here is 0.05. And because this is normal, we are going to do as follows. This is 0.05. But because this is a normal distribution, we need to find this area right here, right? Because the normal distribution table in this textbook gives you this area, right? So that means this is 0.45. Now, this is an area of 0.45, so we need to find the critical value right here. Now, you go to the normal table and look for 0.45 inside, right? 0.45 will be somewhere in here. If you look at this table, you go 0.45, it will be between 0.4505 and 0.45, oops, sorry, 0.4495 and 0.4505. The corresponding value is 1.64, maybe 1.65. So this right here is 1.65. Or maybe 1.64. You can use either one, right? Now notice this is on the right hand side, so this is positive. All right, now we haven't finished all the steps, right? But we are sort of accumulating step by step by step. So we have a claim. We have a claim, and we are given an alpha. With this data, we do the null hypothesis and the alternative hypothesis. And then from this, we are going to do the graph, and then the graph will give us two areas, so the null hypothesis and the alternative hypothesis. And then there will be, this is called a critical value, and this will be the cutoff between the null and the alternative. Now, we need to decide now where in these areas the sample lies. And once we determine that, we are going to find which one you accept, either the null or the alternative. Well, all right. And the missing step here is finding where the sample is. So step number one will be to do the hypotheses. This one is always equal, doesn't know. This will be on the right hand side, more maybe on the left. Step number one, that will be the hypothesis. Step number two, you need to do the graph and then the cutoff. And the step number three will be find the sample. Now, we don't have, of course, enough information to find the sample, but we are going to do that in a minute. Finding the sample is going to help us determine which one we accept, the null or the alternative. Now, there's basically one criteria alone, right? If the sample is here, you will accept the null because this is the null area. If the sample is here, you will accept the alternative because that's where the alternative lies. And we don't know yet how to find the sample, right? We are going to find that in a minute. And, well, as a matter of fact, we are going to find the sample using a formula. And let me tell you, in chapter 10, at the end of chapter 10, we have the formulas to find the sample. It depends on the context, but we are going to find the sample by using either of three formulas, right? So we find the sample using 10.1 or 10-1 or 10-2 or 10-3, depending on the context. All of these formulas, this is formula for one case, formula for another case, formula for another case, are on page 317. All right. I'm just going to do one problem, and that will be the end of this video. The problem I want to do is problem 6 on page 3 or 4. Let me erase this. So let's talk about problem 6 on page 3 or 4. Problem 6 on page 3 or 4. And this is the problem. See, a survey, no, wait a minute, that's not it. The waiting time for customer at this restaurant follows the normal distribution, right? And the population standard deviation is 1 minute, right? So we know this is about waiting time. So waiting time at this burger restaurant is called Mac Burger. It's normal, right? And the first thing we are being told is this, that the standard deviation of the population is 1, right? The population standard deviation is 1, so sigma is 1. And then we are going to sample 50 customers, right? So the sample is 50, and that means n, little n, is 50. We are going to need all of these in a minute. And then the mean waiting time was 2.75. Now the sample mean, that's what we're talking about, right? We take 50 customers, and then we find their time for each one of them, and then at the end we find the mean, and that means that we have the sample mean. In this case, x bar is 2.75. Now, notice that it tells you at the 0.05 significance level, right? So that's the easy problem to find, or the easy number to find. That will be alpha which is the significance level of 0.05. And remember, this is easy to find because it will always be given, right? It says, you will say the significance level is 0.05 or the significance level is 0.01, something like that. But you will always have this one. This is easy to find. All right, at the 0.05 level, the problem is, can we conclude that the mean waiting time is less than 3 minutes? This is the claim, or this is the question. Let me phrase it as a claim. Is it reasonable, or can we assume that the waiting time, the mean waiting time is less than 3 minutes? This is the question, or this is the claim, right? Now notice this is phrased in terms of less than, but it doesn't really matter because the null hypothesis will always be equal. And as a matter of fact, that's the first thing we need to do, right? The first step. All right, so this is the problem. And the solution to the problem is this. And let me start here. The solution. I'm going to have to erase that in a minute. But the first thing is, you have to do the null hypothesis and the alternative hypothesis. Now, the null hypothesis is always about equality, right? So you have to say that the mean is equal, regardless of what the claim is. As a matter of fact, the claim is that the mean is less. Regardless of that, you have to say that the null hypothesis is that the mean is equal to 3 minutes. This is always equal. Now the alternative, well, see, the claim is that the mean is less, so the alternative has to be that the mean is less than 3. And remember, this is about the mean of the population. This is the same number, even though it looks different. But this and this are the same label. And this number are always the same. Now, this is the first step. The null hypothesis and the alternative. Again, right, the null is always about equal. The alternative is about maybe less than or maybe greater than. But then you have the second step. And let me go up here. The second step will be the graph. Now, we know this is a normal distribution. Now, we know this is a normal distribution because we know the population is standard deviation, right? If we didn't know this number, you will have to use the t-distribution. But for right now, this is a normal distribution problem. Now, notice that the null is that the mean is equal. All right, so that will be in the center. And then the alternative is that the mean is less than. This less than implies that you have an area on the left. Now this area is determined by the significance level, right? So it will be 0.05. And you have to find this cutoff. The second step implies that you need to find this cutoff. This is called the significance level. Now, remember this is normal because we know sigma. So how do you find this number? There's a couple of ways to do this, but let's start by doing this. This being the normal distribution, we have to find out what this area is. Now this would be 0.45, right? Because this would be half of it. And this is the area on the table. All right, so if you look at 0.45 inside the table, like we did earlier on the normal distribution, look for 0.45 somewhere inside, you're going to find, again, 1.65, or maybe 1.64. All right, so this is 1.65. Just one little thing. This is on the left, because this one says less than, right, so on the left side, on the far left, so this will be a negative 1.65. Now, you will have two areas, the null hypothesis in the center and the alternative on the far left. Now we need to find which one we accept, the null in the center or the alternative on the left. And we are going to do that for step number 1, that's the hypothesis. Step number 2, the graph. And step number 3, we find the sample. Now we find the sample by using, well, at the end of the chapter, right? Either 10.1, 10.2, or 10.3. This is on page 317. Page 317. Now, we are going to use 10.1, and the reason is, this is about the means. All right, so the means formula, the means formulas, will be 10.1 or 10.2. 10.3 is about percentages. We'll talk about percentage later. But 10.1 and 10.2 is about means, and we are going to use 10.1 rather than 10.2 because we know sigma. Notice that 10.1 implies that we know sigma, which is the population standard deviation, right? So on page 317, we are going to use 10.1. And 10.1 is z equals x bar minus mu divided by sigma divided by the square root of n. You can look up this formula on page 317. Now notice we know x bar, which is the sample mean. We know sigma, we know n, and then notice mu. Well, we know a mu, or we are assuming mu to be 3, right? So you can actually go and find z value. And, well, let's find the z value from this one. And all right, so you have x bar. X bar is 2.75 minus mu, which is 3, and then you divide sigma, that would be 1, and then you divide by the square root of n, which is 50, and then, all right, so you have this amount. And we need to find it, z. You need to find this. And this is the step where we find the sample, right? In the sample, it is going to be this number, which we'll find in a minute. And I forgot my calculator. I'll find it in a minute. So this value right here, it is going to be either here, somewhere here, which means we accept the null hypothesis, or here, which means you accept the alternative hypothesis. And I need to turn on the computer because I forgot my calculator. That is kind of embarrassing. All right, and just to emphasize or to summarize, we have a claim. This is basically the claim. And we are going to test the claim based on sample data. And notice this is all sample data, well, except for this one, but in the context of the sample, you have the standard deviation, the sample size, and the sample mean. And this one will help you either accept or reject the claim, but you have to do this through a couple of steps. Step number 1, do the null and the alternative. Step number 2, do the graph, and this will determine the alternative area and the null area. The null area is always in the center. The alternative will be either here or maybe here, left or right. And then step number 3, you find the sample using a formula. And it is relatively straightforward to find which formula. We are using this formula because this problem is about the mean, and we know sigma. All right, so we use this one to find the formula, or rather this formula to find the sample. And this number that I'm going to find in a minute will either be somewhere in here, or maybe somewhere in here. If it's to the right of this cutoff, we are going to accept the null. If it's to the left, we are going to accept the alternative. We are going to find where the sample is by using this formula. And see, the formula is dividing this by all of this. So you can do this step by step, right? You do 275 minus 3, which gives you negative 0.25. And then you divide 1 by the square root of 50, which gives you 0.1414. You can do all of this in one step, but you can certainly do it in 2 steps. Now, the z value is negative 1.77. And this is going to tell us where the sample is. Now, notice this is minus 1.77. So that implies that the sample is to the left, because this is basically the center, 0, minus 1, minus 1.65, minus 1.77. So this is where the sample is. Notice the sample is going to determine which hypothesis we accept. And we have only 2 possibilities: the null in the center and the alternative on the left side. We are going to accept the alternative because this is right here, right? Notice this on the alternative area. So we are going to accept the alternative. Conclusion, and this will be the end of this problem, we have to accept the alternative. Because we are trying to find out whether the mean is less than 3. Notice we are accepting the alternative, meaning we are accepting this, right? And the alternative says that the mean is less than 3. So the answer is yes. The mean is less than 3. And all right, so this is the end of the first video. This is the end of the first problem. And we are going to do another video with a couple of more problems, and we will practice later. All right. Cut.